Understand the concept of the rate-determining step. In a multi-step chemical reaction mechanism, the overall rate of the reaction is determined by the slowest elementary step, which is known as the rate-determining step. Identify the rate-determining step from the proposed mechanism. Looking at the two elementary steps provided. Step 1. Cl plus O3 gives ClO plus O2 is explicitly labeled as the slow step. Step 2. ClO plus O3 gives Cl plus 2O2 is labeled as the fast step. Because step 1 is the slow step, the overall reaction rate is dictated by the rate of step 1. Write the rate law for the rate-determining step. Since step 1 is an elementary reaction, its rate law is determined directly by the stoichiometry of its reactants. The reactants in step 1 are one chlorine atom, Cl, and one ozone molecule, O3, each with a stoichiometric coefficient of 1. This yields the rate law. Rate equals K, Cl, O3. Conclude the overall rate law. Because step 1 determines the speed of the entire process, the rate law for the overall reaction is rate equals K, Cl, O3. Note that while chlorine, Cl, is a catalyst consumed in step 1 and regenerated in step 2, it is a reactant in the rate-determining step and thus correctly appears in the rate law. This matches option B. The correct answer is option B. Rate equals K, Cl, O3.